starting. So okay, so what I was telling is like these virtual machines are also just like your PCs, which are having like an individual virtual machines, like one or more virtual machines on the cloud, like AWS, and each virtual machine will be having its own operating system. So let us think here. I just kept some kind of Windows operating system, and also here I can keep the one more like Red Hat Linux or something. Again, this can have its own applications, and this can have its own applications. Okay, these two are staying where they are staying in some hypervisor or some cloud environment. Okay, and also this will be having some kind of hardware infrastructure which is beneath the layers of the cloud. Okay, so this is how this cloud concept came, where actually we can able to run one or more virtual machines on top of the one or more virtual machines. Each machine again can have different application servers. Okay, so and this AWS or actually cloud, they work in the same format. So they will work with the virtual machines format. Okay, so I think you have got this one, you understood this one. So still, so just like that. So just this virtual machine earlier diagram showed. So actually here also we are having some kind of physical machines with a Docker. So it's like physical machines with a Docker, and it's like hardware infrastructure and also operating system. On top of it, we are going to have a Docker. Docker is just like a wrapper which will get the application servers or web server or this database servers. Okay, so this is just an understanding how the Docker will be sitting on top of the operating system. Yesterday I showed you about actually Linux. On top of it, we have installed the Docker. On top of it, we have run the image, right? Just like that. Okay. So hope you got this one. So the next one is like, so what are the problems with the traditional infrastructure? So here this is like it is having traditional approach. One is like one after other, and also huge cost is there, and also installation and also configuration. So and also it is like very time consuming. Suppose earlier days, if they want to install do one kind of infrastructure. So they want to perform or actually they want to invest a lot of money. Okay, and also time also, and also more resources they want to burn. Okay, so these kind of things we so here and also we need to perform like configurations of every server, every environment. For example, UA staging, production, everything we have to perform configurations individually. Okay, so again for the dev we have to take one more layer. Again for the staging we want to take one more operating system, and also again different server. So likewise actually it was like more expensive, and also compatibility and also dependency is also there. So suppose if there is any problem with the libraries, then then actually we have to update each and every library in the operating system. Okay, so and also so those if one operating system is having some kind of dependencies, the other operating system is I mean, if it is not having, then it is like a compatibility issues will be there for, I mean, for the application servers. That is also one of the disadvantage. Okay. And also
Mm.
inconsistency across environments means where they also sometimes the code will run in dev and the same kind of code if you go and put in some QA and which is there in other hardware. So then what will happen? Sometimes it may break. Okay. Though the code is same, the hardware compatibility won't be there. Okay. Then it is also in one of the biggest issue. Okay. And also operational support. It need more actually resources to handle operational issues on day-to-day basis. Server support, it has hardware and software support, and also patching glitches. So these kind of issues were there. I mean for the I mean operation teams actually. So we need more resources to burn to handle the operation issues. All the time, one person have to be actually sit in the backend to check whether the application is running or not. So if it is down, again you want to inform the developer. The developer again he will check in the next day or within 2 days. Again he will solve. Again this build will run. So this kind of operation issues, once whatever that I mean 2 days of burn, that will be actually I mean it will kill the time of the user. Okay, so that is also one of the important things. So with the traditional infrastructure disadvantages and also developer environment. When a new developer joins the team, the time it takes to the provision this developer environment is like it will consume a lot of time. So one person who joins the team, you want to understand the structure of this software environment. It is like one of the it takes some time to implement. So if you see some kind of 10 years back, 12 years back, or 20 years back, so in IT, somebody is joining into a project, they will give him at least 1 month of KT. They will tell each and every place where which and what files are there. So likewise it was. So even for him understanding and also setting up the environment, it will take a lot of time. Okay. That issues was there with the traditional approach actually. These are the sort of disadvantages of the traditional infrastructure. Okay. So let me go for this one. So with this Dockers, what will happen is like, so you will have same kind of hardware infrastructure which is there in the backend, and also this hypervisor is like a layer which will have this Docker images, Docker virtual machines. So each virtual machine will be having its own operating system. Let one be the Linux, it can be the Windows, or it can be some Ubuntu, or it can be some Red Hat or Mac or whatever it is. Again, this operating system will be having its own web server, and also I mean we can able to install the Docker on top of them. The Docker will be having these containers. This is one container is like an Nginx container, and other container is like some kind of app servers that is a Spring Boot image, and also like one container will be having database image. So likewise, so one Docker image can be having several containers. So, okay, so by this, what will happen is like everything is there. So that I mean, let us think one virtual machine is for sales department, and other virtual machine is for the finance department. Okay, so we can able to actually connect between one Docker to other Docker and also one container to other container easily if it is there in the same environment. Yeah, so last time we saw about Docker bridge. So where we are actually contacting from one container to the other container. From the application perspective, the people can able to, call from APIs from one web server to the other application servers easily. It is there inside in one Docker image. Okay. You got this one? You understood this diagram? So how does the container?
Yes, I understand.
Okay, nice. So next. So next thing is this one, advantages of the Docker. So it is very flexible. A Docker is very flexible. Even the most complex applications can be containerized. I mean, they can be like maintained. We can maintain them as a container, and also it is a lightweight, and also here the containers can leverage and also share the host host names between each and between the applications, and also make them much more efficient in terms of resource usages than virtual machines. That is why actually we are going to I'm taking the Docker because it is lightweight, and also each individual application have its own hosting which can communicate to each other. And also the very next one is like portable. You can build locally and deploy the cloud and run anywhere with the Docker containers. And also it is loosely coupled. So it means like containers are highly self-sufficient and also encapsulated, and also allows you to replace or upgrade one without disrupting others. Means each container is like into individual space, and also the updation of MySQL won't disturb the updation of Node.js updation won't disturb the MySQL update. Okay, likewise it is. And also it is scalable. Scalable means you can increase and automatically distribute the containers replicas across the data center. Means you can able to maintain same kind of images of these containers in different data centers. For suppose one guy is having one data center in India, you can put that container in India, and the same container you can able to install in some other place in UK or something. So both will work, as it is, not as it is, and also the both will have same containerization, right? Both servers will be having actually same parent. So the containers are scalable. So from one system to other system, that they won't change its performance, and also its time delay, uh, nothing will be there. So whatever you are using, other person also can be able to use with the same performance. And also it is more secure. So containers are more secure. So containers apply aggressive constraints and also resolutions to process without any configuration required. So without any actually configuration required, we can able to apply aggressive constraints, and each time when we build a Docker image or Docker container, that will be securely, it will be there within the operating system or the virtual machine. So these are the different advantages we are having with the Docker. So next, so next we will see something about Docker terminology. So Docker is having a Docker daemon. The Docker daemon always listens for the Docker API request and manages the objects such as images, containers, networks, and volumes. So what this Docker daemon will do? So it will always, it will check what kind of request it is going to get. Suppose I am giving some Docker space, container space, ls. So what it will do, it will go and restore the all containers in the Docker. Okay, so it will manage this Docker daemon. Docker daemon is like it's just a one kind of nucleus which is running in the back end of your Docker. What is its duty is its duty is to manage the objects such as images, containers, networks, and also volumes. Okay. So next is like we have Docker client. Docker client can be represented on either Docker host or any other machine. So Docker client will be, it is just like uh, suppose we already I showed you, I mean yesterday with the AWS. AWS is
Voice
not
is
a
breaking.
hello.
Voice is breaking, sir.
Okay.
Hello. Ah, now it's good.
Okay. Actually, yesterday I showed you about AWS. AWS
Ah, sir.
is just like an one where we have created EC2 instance. From that EC2 instance, what we have done, we have pulled the Docker image. Okay, that is just like a client
Hmm.
which is running the Docker. I mean Docker software. Docker client is a primary way that many Docker users interact with Docker. So there are some other ways also to interact with Docker. So how we can able to track this through either with the PuTTY we can do with the Docker client or Docker or CMD we can interact. These are all actually falls with the Docker client where we can able to see the Docker, um, commands. And also, when you use actually commands such as Docker run, the client sends these commands to. So when you use actually commands such as Docker run, then what will happen? Then the client sends what client? Docker client. Docker client will send these commands to the Docker ERT, which is nothing but Docker daemon, which carries out them. What this Docker daemon will do, I already mentioned in the first point. It is like it will manage the images, containers, networks, and also volumes. Okay. So and also Docker commands uses the Docker API, the backend. Okay. It will always be there available in the backend. It is just like an object which is there from the terminal, which is there always available in the backend. Suppose if you give Docker space container space ls, then the Docker API will be triggered and it will get the response back. And also next time if you go for Docker space some PS, so then what will happen? It will go ahead and try the Docker API and also Docker daemon. What it will do? It will go and bring, whatever the containers are there available in your Docker system. Okay. That and all will be happening. And also this Docker client can communicate with one or more daemons. Means one or more you can able to take one or two sessions at the same time and you can run Docker space container space ls or Docker images or some kind of Docker stats or something. So then both will be running from two different clients, but they will run with two different one or more daemons on same time. Okay. And also this Docker image and an image is a so this is just like an image that is a read-only template with instructions for Docker container for creating a Docker container. A image is based on another image. And also, for example, hello, I think, yeah. So, for
Yes, sir.
example, if we build an image which is based on some Ubuntu, but installs we can able to install Apache Web Server in our application, as well as the configuration details needs to be make our application run. Okay, what is this? What is meaning this? So if you are having some Ubuntu operating system, And also if you are, so if you want to run an image of Apache web server, that is a web server which is used for the Java Apache Tomcat web server, so which is used to run the Java applications. So though you are having this Ubuntu image, we can able to run the web server, and also we can run the application there. Okay, and
Okay.
and also Docker container. Docker containers, what it will have? It will have the images. Docker containers will have the images. Like suppose a Docker container is a runnable instance of an image. It is a runnable instance of the image. We can create, start, stop, and move or delete a container by using Docker API or Docker CLI. These are all steps where we can start and stop the application, and also we can able to delete the application. We can pause it. Okay, everything works. Okay. And also we can connect container to one or more networks. So yesterday we saw about how to connect between one or two containers from one container to the other container through the Docker attach and container name. Yesterday we saw it, right? And through that we can communicate between them. We can connect between one or more applications. So when a container is removed, any changes to its state that is not stored in persistent storage disappear. So if anything is like removed, if the container is removed, then whatever the changes you have done inside that container will be removed. For example, you are having some Apache Tomcat server or some kind of Node.js, uh, I mean application. So if you are